Hey everyone, let's take a look at these questions today. The first one, a gardener has 36 meters of fencing to make a circular enclosure. Okay, so this 36 meters is going to be the circumference, okay, the distance around the garden. What's the radius of the largest circle she can make? Okay, so we know that to find the circumference, you take pi and times it by the diameter, okay? In this question, though, we're given the circumference because she only has 36 meters to deal with. So it's circumference equals pi 3.14 times the diameter. Now, if we're going to solve this equation, we're going to divide both sides by pi 3.14. That will isolate the diameter here for us. So once we do that, we get the diameter is 11.465 meters, but of course the question is asking for the radius. So if we know the diameter is 11.465 meters, then we just divide it by 2 and we get a radius of 5.73 meters. So that's how you do that one. Okay, and the next one. Can the area of a circle be the same numerical value as the circumference of a circle? Okay, basically it's saying, can they have the same digits? Like, is it possible that there is a circle that exists where its area and its circumference are the same digits, basically the same numbers? So what we have to do is look a little bit closer at the formulas for each. We know area is pi times the radius, and we know that circumference is pi times the diameter. Okay, now we don't care about pi because they're on both sides. Okay, what we're going to look at specifically is the radiuses versus the diameter. Now, is there a number that we can multiply by itself that would give us, in this case, 2 r's multiplied together to give us the d, the diameter here? So you could guess and test if you want, but I'll just sort of fast forward to the answer. If there was a circle that had a radius of 2, radius times radius, 2 times 2 would give us 4, right? If the circle has a radius of 2, then its diameter is double that, right? Which would be 4. So if you have a circle with a radius of 2, then both its area and its circumference will be 12.56. Okay, the area would be 12.56 meters squared or centimeters squared, and the circumference would be 12.56 meters. Anyways, so that's how that works. The thing you had to watch for here, it doesn't work with any number. You have to maintain the fact that 2 times the radius gives you the diameter. So we couldn't use 3, because 3 times 3, if the radius was 3, then the diameter would be, so this would give us 9, right? And then the diameter would be 6, right? But pi times 9, 3 times 3, is not the same as pi times 6. It only works when the radius is 2 and the diameter is 4. Okay, the next one. What is the area of the shaded region, this yellow part? So basically what we have is a semicircle, half of a circle, with 2 chunks taken out of it. Okay? Now, if we were to put these 2 chunks together and sort of draw them underneath, we would have a full circle, right? This is half, this is a semicircle, this is a semicircle. Together they make a full circle, right? So what we're going to do is find the area of this yellow semicircle, and then we will subtract these 2 chunks out after. So the area of this semicircle, the radius is 4, right? The diameter all the way is 8, so the radius is 4. Pi times 4 times 4 Okay, and then I'm going to divide it by 2 because we have just half the circle, this yellow circle. So we get 25.12 centimeters squared. Now I said we're going to subtract a full circle, okay, because that's what these two little pieces make. Okay, they're two semicircles, but together they will make a full circle. And we're going to subtract that from this 25.12 centimeters squared. Now the radius of these small sort of semicircles is 2, right? The diameter is 4, so the radius is 2. So pi times 2 times 2 gives us 12.56 centimeters squared. Okay, so I'm considering the fact that both of these will make a full circle. So the only math I have to do now is subtract. So the area of the full semicircle is 25.12 centimeters squared. And now I'm going to, look over here, I'm going to subtract this area from it. So 25.12 centimeters squared minus 12.56 centimeters squared is 12.56 centimeters squared. So that's the answer for that one. And number 4 here, they want us to find the area of the outer ring, so the silver part. So how much area does this silver part take up? Well, basically what we're going to do is find the area of the whole circle, okay, the whole toonie, and subtract the area of the gold part on the inside here, or the brass part. So all we got to do is find the area of the whole circle. The diameter is 28, so the outer diameter from edge to edge is 14 meters or 14 millimeters, and the radius of the inner circle is 8 because they told us the diameter is 16. Okay, so the whole coin, its radius is 14 millimeters, and the brass part in the middle, the radius is 8. So we're going to find the area of this and subtract that. So pi times 14 times 14 gives us this, 615.44. The area of the circle on the inside, the brass part, pi times 8 times 8, which is 200.96. And then if we just want to know the silver part, all we have to do is subtract them. So this minus this gives us 414.48 millimeters squared. And that's how you do those.